So remember, right now we're looking at area under a curve by drawing in rectangles of equal width. And the problem that we're having from getting a correct answer is that we're either underestimating, because in this case we're doing left endpoints and our rectangles are all below the curve, or if I were to do right endpoints, then I would be overestimating. Let's see. So I'd have a little bit of extra. And of course the midpoints help make that a little bit better, but they're still off a little bit, even though they compensate with a little bit over, a little bit under. So what calculates do is they say, well, since we have this extra, what would happen if we simply made the width of the rectangles smaller? So for example, let's say my rectangles get this skinny. So now I still have delta x as the width, but that delta x is getting much smaller. So over here in the formula, here's the width of the rectangle, and remember the height of the rectangle is the y value based off of the x value. So that's really width times length for every rectangle. And so now what's happening is, because I'm making these rectangles smaller and smaller and smaller, then I'm getting a lot of them. Good luck counting. And oh, by the way, when you get them drawn in, I'm going to go, wow, those rectangles are way too wide. You need to cut those in half. So therefore, I'm making the number of rectangles increase to infinity because I'm making them so much smaller. And when I do that, then I don't have all this extra space like I do with the fat rectangles.